For most of human history, we imagine planets as loyal companions, worlds that circle their stars in predictable paths, warmed by steady sunlight, bound to a solar system like a family. We picture planets as members of an orderly cosmic system, moving in graceful orbits around a central sun. But the universe is far stranger than that, because not every planet belongs to a star. Some planets drift alone to the darkness, with no sunrise, no seasons, and no home system. They're called rogue planets, wandering worlds traveling through interstellar space like ghosts. And right now, there may be billions of them in our galaxy alone. The idea feels almost impossible at first. A planet the size of Earth, or even Jupiter, floating through deep space with nothing to orbit. No star provide warmth or light. Yet modern astronomy suggests these worlds are real, and they may be far more common than anyone once imagined. In fact, the Milky Way could contain more rogue planets than stars. So, how does a planet become a cosmic orphan? The story begins in the chaotic violence of planetary birth. When a solar system forms, it is not calm or orderly. A young star ignites inside a swirling disk of gas and dust. Over millions of years, that disk collapses into planets. But in the early stages, everything is unstable. Massive worlds pull on each other. Orbits shift. Collisions happen. And sometimes a planet is thrown out completely. Like a stone flung from a sling, it is ejected into the void. A rogue planet is born. Some are cast out by giant planets, whose gravity can destabilize smaller worlds. Others are expelled during violent encounters between neighboring stars. In crowded stellar nurseries, young solar systems pass dangerously close to each other. One gravitational disturbance can rip planets from their orbits. And once a planet is untethered, it begins a journey with no destination. It drifts through the cold spaces between stars, moving silently across the galaxy. For a rogue planet, the universe becomes an endless night. There is no central sun, no familiar orbit, only darkness and distance. But here is where the mystery deepens. Because a rogue planet is not necessarily dead. Even without a star, some of these worlds may still carry heat. Deep inside, radioactive decay and leftover energy from formation can keep a core warm for billions of years. If the planet has a thick atmosphere, it could trap that heat like a blanket. In theory, a rogue planet could have oceans beneath ice, hidden seas warmed from below, a world drifting through darkness, yet still alive with internal energy. Some scientists have even suggested that life could exist on such planets, not powered by sunlight, but by geothermal heat. Life on Earth depends on the sun, but deep beneath our oceans, around hydrothermal vents, entire ecosystems thrive without sunlight at all. If such environments can exist here, then perhaps they could exist on rogue worlds as well. A planet without a star might still host pockets of warm chemistry and maybe even biology. Rogue planets challenge our definition of what it means to be habitable. They remind us that life may not require a perfect Earth-like orbit around the sun. The universe may have stranger possibilities hidden in the dark. Rogue planets also reveal something unsettling about the cosmos. Solar systems are not permanent or stable families. They are dynamic, chaotic systems shaped by gravity over billions of years. Worlds can be created, destroyed, captured, or cast out. The galaxy may be filled with planets wandering alone, invisible unless they pass in front of distant stars, or reveal themselves through subtle gravitational effects. These orphan worlds may drift for millions of years, passing silently between the stars, carry with them the history of the systems that rejected them. Detecting rogue planets is one of the greatest challenges in astronomy. Because they do not orbit a star, they do not reflect much light. They are cold, dark, and nearly invisible against the blackness of space. Most of the time, a rogue planet cannot be seen directly. Instead, astronomers must find them through indirect methods. One of the most powerful techniques is gravitational microlensing. When a rogue planet passes in front of a distant star, its gravity bends and magnifies the star's light, creating a brief and subtle brightening. For a moment, the rogue planet reveals itself, not through its own light, but through the way it warps space-time. This method has allowed scientists to detect candidates for free-floating planets, suggesting that they are indeed abundant. Some rogue planets may also be detected in infrared, because young rogue worlds can still glow with leftover heat from their formation. These are not warm like stars, but they may emit faint heat signatures detectable with sensitive instruments. Over time, as they cool, they fade into darkness, becoming almost impossible to find. This means that the rogue planets we detect may only be the visible fraction of a much larger hidden population. The galaxy may be filled with countless dark worlds drifting unseen. Rogue planets raise profound questions about planetary systems and the nature of the Milky Way. If planets can be ejected so easily, then solar systems everywhere may be constantly losing worlds. The night between stars may not be empty space, but a vast ocean of wandering planets. Some may be small like Earth. Others may be massive gas giants. Some may carry moons, frozen companions orbiting in eternal darkness. Some may even have thick atmospheres that trap heat, creating strange twilight environments beneath layers of cloud. A rogue planet could travel through the galaxy for billions of years, passing near star systems without ever being captured. But capture is also possible. In rare cases, a rogue planet could be pulled into orbit around a new star, becoming an adopted world in a foreign solar system. The galaxy may exchange planets the way it exchanges comets and dust, creating systems shaped by cosmic migration. Rogue planets also push our imagination toward the distant future. If humanity ever becomes capable of traveling between stars, rogue planets could become stepping stones, isolated outposts drifting through interstellar space. They could contain resources, frozen water, or even hidden oceans. They could be places of mystery, worlds without suns, wandering endlessly in the cosmic dark. And perhaps the most haunting thought is this: there may be rogue planets passing near our own solar system right now, unseen, silent, moving through the outer darkness. The universe may be far more crowded than it appears. Rogue planets remind us that space is not only filled with stars, but also with worlds without light. They are cosmic exiles, carrying the scars of violent gravitational histories. They are proof that planets are not always bound, that the galaxy is dynamic, chaotic, and full of hidden travelers. In the end, rogue planets expand our understanding of what a planet can be. They show us that worlds do not always need a sun, that darkness does not always mean lifelessness, and that the Milky Way may be filled with wandering Earths, drifting quietly through the endless night. Somewhere out there in the cold space between stars, countless rogue planets continue their silent journeys, unseen by most, yet shaping the hidden architecture of our galaxy.